Okay, so if we can start with, I guess, a UPS and yourself, Power Control Ltd company, in terms of the role you would see both for you and your technology, the data center industry is under a lot of pressure to do with energy efficiency, sustainability. So, the short answer or the long answer, what do you see as your role and the UPS's role in helping folks, focus on those issues?
Yeah, so there's obviously big demand for UPS, and it is changing, and the way that people are using UPS is changing to make them much more efficient or better utilize them and size them a little bit more accurately. And well, our role is really to help maximize that. We work obviously with different manufacturers, so we're not tied into what we've got sitting in the warehouse or from what the factory wants us to be pushing a lot sooner. We can have a look at what the requirement is and work out the best solution for that. Almost more like a UPS consultancy rather than just supplier and installer.
And just in terms of the technology, just curious, I don't know whether go back 5 or 10 years, what sort of developments have there been that make the actual UPS itself a bit more energy efficient? I don't know if it's adding intelligence to it, different actual design of it, but can you talk us through that a bit?
Yeah, so obviously 10 years ago, majority of UPS would have been transformer based. And so you'd have had all the transformer losses in there. Now they're not there included. You don't need the transformer. So that's obviously saved 2 or 3% on your efficiency straight away. You've had changes with your rectifier technology. You've got different inverter technologies now. And while on their own are only small differences, but added up, they can make 2, 3, 4, 5%, or perhaps even 10% more efficient at the lower loads. So traditionally, while a unit might have been, say, 94% efficient, that might have been at 90% load, for example. Obviously, in data center, generally speaking, you won't go above 40% load, especially if you've got a 2N AB system there. So most people, manufacturers are now, they use the 40% for hitting the peak efficiency. And so you'll now be hitting, that 96, 97% at 40% load. But there are quite a few that even down at 20% load now, you'll be hitting 93, 94% efficiency as well.
Okay, and in terms of, slightly broader issues, do you have a role to play? I know things like sort of power purchase agreements, and there's a talk about the sort of demand response. People obviously have different views as to how sensible that is. Do you get involved in those discussions with customers, or do you just do what you're asked to do, as it were?
Well, we do what we're asked to do, and obviously, like you said, there are quite a few customers that are interested in that, because there's a lot of marketing around on it, and there is interest. Now, my personal preference is to use peak shaving rather than the demand response. It has the same effect, so I'm not sure if you know what peak shaving is, but that's where you can cap the input to the UPS. So say it's a 2 megawatt system, and so obviously you'd normally have supply coming in for everything at that, or perhaps a little bit higher, but then that can be reduced down to a 1 megawatt input. So, and then the UPS will load share between the mains and the battery, and it'll use the battery to top up what's missing for a short amount of time. Obviously, you do need to oversize the battery a little bit to do that, but that is personally, I think that's a better way of doing it rather than exporting back onto the grid.
Okay, and in terms of that, is that just because you think it's a bit more controllable and they're sort of therefore safer for the data center doesn't suddenly find out it's giving away a load of power that it suddenly needs? Is that the basic idea?
Yeah, well, it's not only that, it's also that it's much more simple. You don't need to be looking at any of your synchronizing back to the grid. You've not got any of those complicated controls. It's something that's just done entirely within the UPS, and it's no different to when you're doing a battery test. and you're doing things like that, it's just a standard function that is tried and tested.
Okay, so in terms of that compared to demand, I mean, is demand response just the sort of the current buzz thing, so everyone's talking about it, and why isn't there the same focus? Is it just because people already do the peak shaving and therefore don't bat an eyelid, or do you think there's more could be done to promote the benefits of that as opposed to the demand response side?
I think, to be honest, a lot of people look at that demand response side and they see it as potentially getting some money back, because they say, okay, yeah, we're going to be able to ship 1 megawatt back onto the grid. Well, personally, and again, it is only personal opinion, I think it's for what revenue you get from that compared to the rest of what a data center generates, it's that small in comparison. Why run that risk? Have something that's tried, tested, simple, but it actually has the same effect on reducing the demand from the grid.
Okay, that makes sense. In terms of, I don't want to do the segue from risk to this, but I perhaps it's too tempting to avoid. But lithium-ion batteries, I know there's the very slight risk I think people focus on about, you know, the fire situation, but they clearly are a growing sort of trend in data centers, that there are some clear major benefits, and I think the fire risks such as this can be mitigated. So can you just give us some thoughts as to, you know, lithium-ion batteries, where they're making inroads, why, and how they can be managed?
Yeah, so there are different technologies on the lithium batteries. So you've got your LFP, which is one that most use these days, and that's actually safe. You've not got much of a fire risk because it doesn't self-generate oxygen as part of the chemical reaction, which some of the other types of lithium do. So I actually discount that really as a big risk. Again, that's only my opinion, and other people might and do think differently. But it's like almost, I look at it almost like a hybrid between a standard VRLA battery and then your super sort of lithium, where you're talking super condensed, high discharge, but very volatile. This sort of sits halfway between. So you've got the advantages of both really on that sort. And yeah, the prices of those is coming down considerably. It's more understood technology. It works. Most UPS manufacturers now are able to work with it very easy. So you get rid of all the complicated recharge cycles, all the algorithms and all that sort of nonsense that makes them quite difficult to use. And yeah, it just works.
And so do you think, again, there's maybe a need to have a slightly more sophisticated discussion then about lithium? You obviously mentioned and you've explained there are different varieties. So yeah, everyone, well, as I just asked you the question, you know, lithium-ion batteries, one assumes they all do the same, but they clearly don't. So I say, do you think data center owners, operators need to be educated a bit more as to, you know?
Yeah, I do think there is a big element of education that's needed out there, because quite a lot of people just see these pictures of your big energy storage systems, which are using the highly volatile technologies for lithium-ion, and catching up on flames and not being able to be put out for a week until they self-extinguish. But that's going to one complete extreme. The flip side is, you know, like your mobile phone. When you really hear of someone's mobile phone catching fire.
That's better.
Yeah, there's different technologies on all batteries. VRLA batteries are just as susceptible to going into thermal runaway and having a problem, and that will cause just as much damage. It's all, it's as much as anything, it's a sort of mental factor for the risk. And if people have got that better education, then it's great. I mean, at the same time, a lithium battery is not always going to be the best option for someone anyway. Personally, the improved TCO that most people call and say this is why you should go with lithium, well, it's unproven. There aren't any lithium installations out there on UPS that have been there for 15 years. So how do you know that they're going to last 15, 20 years? But if you've got the space available and you've not got any weight constraints, stick to VRLA, unless you're wanting to do cycling. If you've not got that sort of situation and you're tight on space, you want to do sort of peak demand, peak shaving or demand response, you need lithium because you're going to be cycling the UPS or the batteries. And that's when lithium really kicks in and is a good idea.
Okay, and I mean, longer term, I mean, clearly lithium, yeah, gets dug out of the ground, so I guess there's a sustainability issue with that. But I'm intrigued as well with hydrogen fuel cells. I mean, they're not new, but people are talking about them a bit more positively, shall we say. Do you have any thoughts as to their sort of suitability, you know, for data centers, and any kind of time frame as to when they might become, you know, more accepted in that environment?
The main problem with fuel cells is scaling them up to any meaningful power for data centers. We've had probably more exposure to them than most other UPS companies. So we've been working with companies and they actually needed a UPS with the fuel cells to make them work. So the biggest problem that a fuel cell has got is if it's a steady amount of power required, it's fine. But if it's constantly changing, fluctuating power requirement, the fuel cell needs to ramp up and ramp down, and it can't do it immediately. So you normally end up having to have a UPS or battery or something there to be able to take those, basically to take the peaks and the dips. So the fuel cell's got a steady, constant requirement, then the UPS takes the rest.
Okay. And in terms of the UPS as the, I don't know whether to call it the hero of the data center, but how important is a UPS in terms of helping data centers, you know, grow, the designs change, update, modernize, growth? And I'm thinking also maybe, you know, in the hyperscale environment, do they help, you know, the evolution of those kind of, what sort of role, I guess, does the UPS have there in a modern data center?
Well, fortunately for me, they have got a big role. Obviously, I don't think anyone would want to buy a UPS if they didn't have to. I mean, why would you? But again, technology on UPS and things that are changing with that is the actual size of the UPS in terms of rating are getting bigger and bigger. And I think that's been driven by the hyperscales, where they're wanting to have obviously larger and larger data halls in terms of kilowatt rating or different things, and well, just the sheer size of these things. So you're going from looking at sort of 500 kilowatt building blocks of UPS perhaps to 2 megawatt building blocks of UPS. So, and that's only really been available recently over the last couple of years as manufacturers have seen that requirement and develop units to be able to do that.
Okay. And I'm just thinking on the flip side, it may be a stupid question, may not be, but the edge was being talked about a lot on the other, you know, so you're talking about, you know, larger and larger UPS. Yeah. Conversely, is there any call yet? Do you seeing for, you know, much smaller UPS to run at, you know, I know the edge is a very difficult thing to define, but I'm talking, you know, but maybe at the, you know, street corner kiosk level where people are talking about, you know, having minute little data centers running autonomous vehicles or whatever it is. Are you seeing any demand for that side of things?
No more than normal, to be honest. I mean, we do supply a lot of sort of 1 kVAs all the way, obviously all the way up through to the big, but yeah, I think the sort of 1 to 3 kVA market with a little internal lithium battery, so it keeps that footprint down, so it can fit inside the street side cabs a lot easier. We are seeing quite a growing requirement on that from different companies.
Okay, and in terms and as we wrap up, the sort of advice to you, we've covered a fair amount of ground. what would you tell people, either if they're buying UPS for a brand new facility, if they're lucky enough to have a shiny new data center, what to do, or if they're aware that their UPS is getting old, or they're looking whether they can get any mileage out of a modern UPS? Any sort of bits of advice as to what they should be asking a potential supplier?
Ongoing service, the cost for that, availability of parts, but also looking at how to future-proof that install. So I've not seen, I've been in the UPS industry for quite a while now, and I can't remember seeing any UPS that's been installed for 10 years actually running at the design load that it was ever designed for. Certainly not in the data center market. So having something that can either scale up or scale down to the requirement, I think could be a big plus for them.
Okay, so in terms of that's what more modular design, is that right? So you can,
yeah, well, not necessarily only modular, but you've got scalable as well, and it depends on what you consider as modular, because you have UPSs that have obviously got your slotting modules vertical, or then you have the ones which is an IO box, and then they scale out with 300 or 400 kilowatt chunks that sit on the side. So it all depends on what you consider modular. Both, I suppose, are modular in some respect, but again, personally, I call it modular, where it's a module that you can physically put in yourself, rather than the other one, which I call a scalable.
Yeah, and just on the service front, I mean, I'm guessing there's a whole gamut. To a certain extent, you'll get what you pay for, but what is there an optimum service regime that you might be expecting to have, or you as a company would if you said to a customer, this is the best way that you should be, or we can help you look after your UPS system?
Yeah, again, I think that it is a balance, isn't it? Because like you say, you get what you pay for, and there's also the thing of what's necessary. If it's a nice, clean environment, you don't need someone going in there every 2 months, to clean it out and things. So majority of data centers, I think, either an annual for a main service and do firmware updates, check everything, with a probably 6-month sort of minor service, where you're giving things more of a visual and it's non-intrusive visit. Just make sure there's nothing there that's untoward. But with remote monitoring and other tools like that, you can probably eliminate the need for that visit.
Fine enough. Yeah, I was going to ask, and I promise this is the final, but on that the remote monitoring side, is that, I mean, clearly it's been about for a while, but everyone's talking about AI and machine learning and all these amazing automation. Yeah. Is that, I say, is it already there, or are there more things, do you think, that to come slightly around that side of things, as you say, remote management, monitoring, etc., of UPS?
Yeah, I think there probably is more to be done, but it all comes down to what's required. It depends what the demand is. Same as anything, pretty much anything's possible, but is it practical? And will people actually want you to do that? The technology is pretty much there to be able to do firmware updates on UPS remotely. I mean, you already do firmware updates on your computer or on servers remotely. So you can do it on a UPS, but who would actually want to do that? You'd always want an engineer there in case there is a problem, because obviously a UPS, it's not just, well, it's only one piece of equipment. If that has a fault, the implications are quite huge. Okay, well, that's great. I mean, we covered a fair amount of ground, and I've certainly learned quite a lot about UPSs. So, Rob, thanks very much indeed for your time. No problem. Thank you.